Sluggish performance. Have you ever tried to run a marathon while breathing through a tiny straw? That is exactly what sluggish performance feels like for a computer. When you click on an application and it takes forever to open, or when moving your mouse across the screen feels like dragging it through thick mud, the system is struggling to keep up with the demands you are placing on it. For your CompTIA A+ Core 1 exam preparation, you need to know that sluggish performance is rarely a random software glitch. It is almost always a physical bottleneck happening right on the motherboard, within the processor, or inside the memory modules. When you are working on achieving that perfect score of 900, you must be able to diagnose exactly which component is choking the system and how to resolve it systematically. The most common hardware cause of a sluggish computer is a defensive mechanism called thermal throttling. The central processing unit is the brain of the computer, and as it thinks and calculates billions of operations per second, it generates a massive amount of heat. If the cooling system fails because a fan stops spinning, or because the heatsink is clogged with years of dust, or because the thermal paste between the chip and the cooler has dried out into a crusty powder, the processor gets dangerously hot. To prevent itself from physically melting and causing a fire, the processor will intentionally slow down its clock speed. It decides to do less work so it generates less heat. As a technician, if a user complains about sluggish performance, your first step should be to check the internal temperatures using diagnostic software or the basic input-output system hardware monitor. If you see the processor hitting 90 or 100 degrees Celsius, you have found your bottleneck. You will need to open the case, blow out the dust, clean off the old thermal interface material, and apply a fresh, pea-sized drop of new thermal paste before securely reattaching the heatsink. Another major physical cause of sluggish performance is a severe lack of random access memory. When a computer runs out of physical memory, chips to hold the active programs, it does not just crash. Instead, the operating system tries to survive by using a trick called paging or swapping. It takes data from the ultra-fast memory and writes it temporarily onto the much slower hard disk drive or solid-state drive. Because even the fastest storage drive is significantly slower than actual memory chips, the entire computer comes to a grinding halt while it waits for data to be shuffled back and forth. You can diagnose this on the exam by checking the Task Manager or Resource Monitor. If the memory usage is constantly sitting at 99% and the storage drive activity is completely maxed out just from opening a web browser, the system is starving for memory. The professional fix for this hardware issue is to consult the motherboard manual, purchase matching modules, and physically install more memory to give the processor the breathing room it needs to work efficiently. Sometimes, sluggish performance is actually a symptom of a failing power supply unit or a motherboard struggling to distribute electricity. Modern processors and video cards are designed to draw extra power in short bursts to boost their performance when you open a heavy application or start a complex task. If the power supply has aging capacitors that cannot deliver that sudden spike in required wattage, or if the voltage regulator modules on the motherboard are overheating and failing, the system cannot enter its high-performance boost state. Instead, it stays locked in its lowest power, lowest speed configuration. This makes the computer feel incredibly slow, even though the temperatures might look completely normal. You would diagnose this by using a multimeter to ensure the power supply is providing a perfectly stable 12 volts under a heavy load. Finally, you must consider the physical condition of the storage drives connected to the motherboard. While we often think of hard drives as just storage, a mechanical drive with failing read and write heads will cause massive system-wide sluggishness. Every time the operating system tries to read a basic file, the broken drive has to try dozens of times to successfully read the magnetic platter. This creates an enormous queue of delayed operations, freezing the entire computer while the motherboard waits for the drive to respond. By checking the self-monitoring analysis and reporting technology status of the drive, you can predict this failure before the drive completely dies. By understanding these deep physical connections between heat, memory, power, and storage, you will easily master the sluggish performance troubleshooting questions on your certification exam.